It's not a car. It's not a drone. And it's definitely not the kind of invention you'd expect to see at a campsite. Yet, within a quiet workshop far away from the noise of Silicon Valley, Maxwell Chikumbutso has just unveiled something that could change outdoor survival forever. Most camping gear today is either heavy, unreliable, or dangerously outdated. But imagine a single device that replaces your generator, your cooking setup, your emergency beacon, your water purifier, and your heating system without using fuel, batteries, or solar panels. Sounds impossible, right? Well, that's exactly what Maxwell has been working on. And today, we're getting a closer look at what may be the world's most advanced camping innovation. This device, codenamed Project Emberstone, doesn't look like much at first glance. It's about the size of a toolbox, with sleek carbon panels, a retractable antenna, and a modular rail system for additional components. But once activated, everything changes. Inside Emberstone is a microenergy harvesting core that pulls ambient RF and kinetic energy from the environment, storing it in a high-density capacitor bank. That means no gasoline, no chargers, no solar, just clean, constant power anywhere on Earth. In the middle of a forest? Still charges. Inside a canyon? Still powers your equipment. On a stormy night with zero sunlight? Still operational. But Emberstone is more than just a portable power source. It comes equipped with a tri-layer survival system designed for real-world emergencies. The first layer is a 360-degree thermal cooking plate embedded into the top panel, capable of heating metal cookware, boiling water, and sterilizing tools, all without producing smoke or open flames. The second layer is a high-efficiency water purification cartridge. It filters river water, lake water, and even muddy puddles using a combination of UV sterilization and nanofiltration. Adventurers who field-tested it in remote regions reported they could drink directly from the output valve within minutes. But it's the third layer that shocked the outdoor community the most, an integrated emergency communication node. With a single antenna and a tiny RF transmitter, Emberstone can send distress signals, location data, and short bursts of audio communication over long distances, even without cell towers or satellites. Survival experts called it the first truly off-grid lifeline. Footage from Maxwell's demonstration shows Emberstone powering an induction cooker, charging multiple devices, purifying water, and broadcasting an emergency message, all simultaneously, without shutting down. Observers were stunned. One engineer at the demo reportedly said, "This isn't a gadget, it's an entire emergency infrastructure in a box." But Maxwell didn't design it just for camping or survivalists. His team believes Emberstone could serve hikers, researchers, military rescue teams, wildlife rangers, remote villages, and even disaster zones where infrastructure collapses. In 2023, the world saw more than 400 major natural disasters, floods, earthquakes, wildfires, leaving millions without access to electricity, clean water, or communication. Emberstone is built for those moments. It doesn't just provide convenience, it provides resilience. And according to Maxwell, this is only version 1. Field tests are currently being conducted in extreme environments: deserts, rainforests, mountain ridges, and frozen tundra. The device is being pushed to its limits, and so far, the results have been promising. But the story doesn't end here. During high-altitude tests in the Andes, Emberstone's core didn't just survive, it performed more efficiently. The thinner air allowed heat to dissipate faster, enabling the induction plate to boil snow water in record time. Researchers at the site recorded stable energy output even with temperatures plunging well below freezing. Then came the rainforest trials. In the Amazon, humidity and dense foliage are notorious for killing off-grid electronics. Moisture corrodes contacts, moss grows over solar panels, and radio signals get swallowed by the canopy. Yet Emberstone powered satellite tablets, camera rigs, and hydration pumps without needing so much as a dry towel. The RF harvesting module actually improved in performance due to the abundance of naturally occurring electromagnetic noise. One ranger who participated in the field test said, "If you dropped me in the jungle with only this box and a machete, I'd walk out alive." But perhaps the most revealing test was conducted in complete silence, far away from civilization. deep inside the Sahara. No cell towers, no radio chatter, no power lines, nothing. Just open desert and the sun beating down on endless dunes. Even there, day after day, Emberstone delivered stable power output, proving it didn't rely on artificial RF sources. It harvested energy from natural atmospheric radiation, thermal differentials, and small electromagnetic signatures produced by the Earth itself. At night, researchers used Emberstone to cook food, sterilize drinking water, and broadcast location signals to a remote tracking station over 100 kilometers away. No batteries died. No fuel ran out. The prototype simply kept going. Maxwell's engineers documented the performance meticulously, compiling data for failure analysis. But there was a problem. There weren't any failures. Capacitor health remained high. Transmitters stayed cool. Filters never clogged. For a prototype, that's unheard of. Once the field trials concluded, the prototype returned to Maxwell's lab for a different kind of testing, human-centered design. Because it wasn't enough for Emberstone to work, it had to make sense to the average user in the middle of panic, exhaustion, or injury. So Maxwell handed the prototype to groups of ordinary people, hikers, campers, fishermen, off-grid families, and even teenage students with no technical background. They were asked to set it up, operate it, and switch between cooking, water filtration, and emergency broadcasting with zero prior training. They succeeded every time. The UI was simple: one main dial, two switches, and a color-coded indicator strip. Maxwell removed screens, menus, and complex controls on purpose. His philosophy was brutally practical. If someone's life depends on it, it shouldn't require a manual. Meanwhile, discussions about distribution began quietly. NGOs saw value in deploying Emberstone to disaster-stricken regions. Military rescue teams wanted ruggedized versions for rapid response. Preppers and survivalists began speculating online. Outdoor brands showed interest in licensing agreements. Tech analysts debated the global implications of portable infrastructure in a box. Because that's what Emberstone represented: portable infrastructure. Not a gadget. Not a toy. Not a luxury. A self-contained microgrid for survival, exploration, or disaster relief. But as excitement grew, so did skepticism. Critics questioned the science behind RF harvesting at this scale. They argued it would violate conventional electrical engineering limits. Some called it hype. Others demanded third-party validation. Maxwell welcomed the challenge. In fact, he anticipated it. So he prepared something bold: a public demonstration under controlled scientific scrutiny, with independent engineers, university researchers, and emergency response professionals observing. The date was set. The location chosen. The demonstration would reveal not just what Emberstone could do, but how far Maxwell was willing to push the boundaries of outdoor survival technology. News of the demonstration spread fast. Tech channels speculated about hidden batteries. Outdoor forums argued about electromagnetic harvesting theory. Engineering students tried to reverse engineer the concept from blurry demo images. But none of that compared to the curiosity of the people invited to witness the real thing. When the day finally arrived, a crowd gathered at the test site, an isolated woodland clearing chosen for its lack of infrastructure. No cell service, no power lines, no generators, no vehicles within sight. Only trees, dirt, wind, and a temporary observation tent filled with fold-out chairs and measuring equipment. On one side stood Emberstone, placed on a flat stone slab. No cables feeding it. No solar panels. No gas canisters. Just the device and its small metal antenna extended skyward. One by one, Maxwell invited the observers to inspect the setup. Engineers crouched down to check for hidden wiring. Technicians scanned for heat signatures or concealed lithium packs. One university researcher brought a Gauss meter to detect magnetic fields. The inspections revealed nothing out of the ordinary. Nothing that could explain how this device would power anything. Then the demonstration began. Maxwell turned a single dial to the first notch. A soft electrical hum resonated from within the casing, barely audible but unmistakably alive. Two engineers monitored the output on their meters and watched as voltage began stabilizing at usable levels without any external power source. Maxwell placed a pot of river water on the induction surface. Within seconds, light shimmering heat distortions appeared above the metal. A thermal camera mounted in the observation tent confirmed rapid heating. The water boiled. The engineers exchanged glances, impressed, but trying not to show it. Next, Maxwell connected a portable rescue radio, a drone charging dock, and a rugged satellite tablet to Emberstone's power ports. All three devices came online simultaneously. Drone battery status bars filled. Software updates loaded on the tablet. The radio broadcast test pings to a repeater far outside the forest perimeter. Still no fuel. Still no solar. Still no explanation from Maxwell. Then came the part that silenced the skeptics. Maxwell lifted a bucket of muddy river water and poured it into Emberstone's filtration chamber. The crowd watched as the liquid passed through a small, transparent window, switching from brown to clear as it moved through the nanofiltration membrane. A few seconds later, clean water poured into a steel cup. Maxwell drank it without hesitation. But the final test was designed specifically for the emergency response teams. Maxwell flipped the antenna module forward and pressed a single red switch. The emergency node activated. Observers watched the telemetry screens in the tent as Emberstone broadcast a beacon signal. Data packets were picked up by distant receivers and relayed back to the test site with geolocation markers attached. No satellites. No cell networks. No external grid. Just a box in the woods sending its location across vast distance. The emergency personnel in attendance didn't clap, they analyzed. They whispered. They pointed at maps and signal logs. To them, this wasn't about hype. It was about implications. When the demonstration ended, Maxwell didn't make a speech. He didn't ask for praise or funding or validation. He simply said, "If you can survive the worst day of your life with this device, it has done its job." As the crowd dispersed, discussions quickly shifted from skepticism to logistics. Who would produce it? Who would deploy it? Who would try to stop it? Who would demand control over it? Because Emberstone was no longer just a survival tool, it was a strategic asset. A device that could support communities without infrastructure. A device that could change disaster response worldwide. A device that governments, militaries, and industries would either embrace or fear. Later that evening, after most reporters and observers had left, a smaller group remained around a portable table lit only by lanterns. These were not journalists or influencers. They were procurement officers, disaster specialists, engineers, and quiet representatives from organizations that rarely reveal their names publicly. They wanted answers, not about how Emberstone worked, but about where it was going. Maxwell listened, hands folded, saying little. When they finished, he revealed something they didn't expect. Emberstone wasn't the only prototype. It was just the first. 3 more designs were already in the pipeline, each one tailored for a different environment. One optimized for mountain rescue, one for naval operations, and one classified as urban collapse, a version engineered for earthquakes, war zones, and total infrastructure failure. The urban variant drew the strongest reactions. Those who understood the implications immediately fell silent. A device that could deploy in a collapsing city and deliver power, water, and communication without reliance on grid, fuel, networks, or satellites was not an accessory. It was sovereignty in a box. But Maxwell wasn't done. He walked over to a locked case and opened it. Inside were 2 documents, an international manufacturing proposal and a set of open licensing agreements. Instead of trying to monopolize the technology, he planned to distribute it across multiple regions to prevent any single power, corporate or governmental, from taking full control. It was an unorthodox move, especially in a world where nations battle for control over far less disruptive technologies. The officials at the table exchanged looks, some impressed, some alarmed. One quietly warned that certain governments would not allow such decentralization without resistance. Maxwell acknowledged the threat with a nod. Technology that can keep people alive shouldn't be bottlenecked by politics, he said. If saving lives becomes an exclusive privilege, we've already failed. The conversation paused, heavy, tense, real. As night fell deeper, plans began forming. A UN disaster response unit discussed pilot deployments in cyclone-prone regions. A humanitarian logistics group believed it could change refugee camp infrastructure. A private aerospace contractor saw potential for deep wilderness research outposts. Even the military observers, who had arrived with cold neutrality, openly admitted they had never seen a portable system so complete. By the time the last lantern was switched off, Ember's tone had crossed a line. It was no longer theoretical. It was actionable. The next weeks moved fast. Non-disclosure agreements were drafted. Field units were assembled. Manufacturing partners in multiple continents began negotiating supply chains. Maxwell refused to reveal component suppliers for security reasons, but confirmed one crucial detail: none of the core modules required rare earth metals, which meant no geopolitical choke points and no exploitation of conflict regions. Meanwhile, a different kind of force emerged: public curiosity. Clips of the forest demonstration leaked online. Footage of boiling water, emergency signals, and muddy water turning drinkable spread like wildfire. Outdoor enthusiasts wanted pre-orders. Survival influencers spun theories. Amateur engineers dissected every frame looking for hidden batteries or coils. But the noise online was nothing compared to the call Maxwell received from a government agency days later. Not for funding. Not for partnership. For a warning. They told him certain powerful interests had taken notice, and not all of them appreciated unregulated survival infrastructure entering the world. Maxwell listened carefully. Then he asked only one question: are they afraid of the technology or afraid of who controls it? Instead of retreating, Maxwell accelerated. Within days, he moved key components of the Emberstone program into distributed labs, small, independent facilities spread across different countries. No single location had enough information to replicate the entire system, but each held a critical fragment. Firmware in one region. Coil manufacturing in another. Filtration membranes somewhere else. The antennas were produced by a civilian aerospace supplier that didn't even know what they were for. It was a decentralized supply chain designed to do one thing: prevent shutdown. At the same time, Maxwell announced something completely unexpected: a civilian training initiative. Not for engineers. Not for scientists. For ordinary people. Workshops began popping up in mountain towns, coastal cities, and rural communities, teaching survival basics: water sourcing, improvised communication, shelter construction, and first aid under blackout conditions. At the center of each workshop was a single Emberstone prototype being used as the class's power and filtration hub. To outsiders, it looked like community outreach. To those paying attention, it was industrial-scale field testing disguised as public education. But while the workshops expanded, the pressure increased. 3 different international tech journals published hit pieces claiming Emberstone violated the laws of thermodynamics. Panels of academics debated its legitimacy without ever having seen it. A defense analyst wrote that unregulated microinfrastructure poses a strategic threat. Online critics called it vaporware. Comment sections flooded with claims of fakery. None of it slowed Maxwell down. Instead, he invited a second wave of observers, but this time, carefully selected. They included a former Apollo mission engineer, a disaster medic who worked in Syrian conflict zones, a rural grid specialist from Kenya, a paramedic from northern Canada, a maritime survival instructor, and an energy systems professor with no ties to defense or industry. They met in a remote Highlands facility where an updated Emberstone prototype awaited, lighter, tougher, and more modular than the forest version. The casing was now composite instead of metal, the induction plate was detachable, and the emergency node had doubled in range. For 3 days, they pushed the device to its limits. Altitude sickness simulations, saltwater exposure, long-duration output tests, signal transmission through canyon terrain, water filtration from contaminated sources. Every participant documented the process without NDAs, without restrictions, with cameras rolling. On the morning of the 4th day, something unprecedented happened. The energy systems professor, who arrived openly skeptical, asked Maxwell a single technical question that no one else had dared to voice directly. What happens if Emberstone scales? Maxwell paused, realizing the implications embedded in that question. Scaling meant residential units, commercial units, industrial systems. Scaled meant microgrids, mini-grids, and eventually macro-distributed infrastructure. Scaled meant independence. And independence is where power struggles begin. Maxwell answered as carefully as he could. If scaled, Emberstone could replace certain forms of centralized energy dependency in remote environments. But that isn't its purpose. Its purpose is resilience, not disruption. The professor nodded slowly. He understood exactly what Maxwell meant and exactly what he was avoiding saying aloud. After the evaluations concluded, each expert submitted a private report. Those reports would later circulate among humanitarian organizations, engineering departments, and emergency response networks, all without Maxwell's involvement. Meanwhile, Emberstone's third prototype entered atmospheric cold chamber testing to simulate sub-zero deployment conditions. And just as the team prepared for production planning, a classified letter arrived, hand-delivered, bearing no insignia, no sender, and no formal signature. It contained only a single line. Domestic energy autonomy is not in alignment with current strategic interests. Maxwell read it twice, then placed it on his desk without comment. His engineers watched quietly, waiting for his reaction. He finally looked up and said, "Then we won't focus on domestic markets." One of the engineers frowned. "Then what do we focus on?" Maxwell pointed at a large map pinned to the wall, marked with circles across regions that suffer regular blackouts, disasters, or conflict. The rollout began quietly, far away from any market with lobbying power or regulatory choke points. The first mass deployment happened after a cyclone ripped through a coastal region in Southeast Asia. Communication towers were down, water treatment plants offline, roads blocked for kilometers. Relief teams arrived late and understaffed, yet in the center of a makeshift camp, an Emberstone unit powered medical lamps, boiled water, charged radios, and filtered drinking water for dozens of families. No press was invited. No speeches were made. But word spread, first to aid workers, then to logistics coordinators, then to disaster planners around the world. The second deployment happened in a rural mountain village that had never been connected to the national grid in its entire history. For the first time, school tablets charged. Weather radios operated. Clean water flowed. Not because a corporation built infrastructure, but because a small device arrived in a backpack. By the time the third deployment reached a drought-stricken refugee corridor, Emberstone units were traveling with medics, not politicians. They operated silently, no diesel fumes, no noise pollution, no endless queues of fuel canisters. Just quiet utility, where utility had never existed. And the reaction from the global stage was mixed. Some nations quietly requested purchase agreements. Others demanded export restrictions. Defense analysts wrote white papers about civilian energy decentralization risk. A major corporation attempted to acquire licensing rights only to discover the patents were already fragmented across multiple jurisdictions. Meanwhile, survival instructors uploaded footage of Emberstone units powering field refrigeration for vaccines. Climbing groups documented their use at base camps. Environmental nonprofits praised their ability to reduce reliance on diesel generators during wildlife operations. As for Maxwell, he refused interviews from major networks. He issued no political statements, no corporate partnerships, no investor roadshows. Instead, he delivered a short recorded message, simple, unpolished, and direct.